Hello everyone. In this tutorial, you will learn how to make a solar system. And in this video, you will learn how to implement the orbit mechanics. Create a blueprint project. Create a new blueprint which will represent a planet. Add a sphere component. And go to the event graph. The first step is to rotate around a point. To do this, use the function rotate vector around axis. You need a variable for the axis. You also need a variable for the speed. Multiply it by delta seconds. Rotate the difference between the actor location and another location which will represent the center of the rotation. Then add this location to the rotated vector. Finally, set the actor location. The first step is done, let's debug the result. Trace a debug line between the actor and the center location in red. Set the thickness to 5. And trace another debug line starting from the actor and showing the axis in blue. Compile. Place a planet in the scene. Rename an Earth. Set the X value of axis to 1. And play with Simulate. The red line shows you the location of the center. Let's check it by changing the values of the center. Let's make sure that the blue line is the axis direction. Now let's see the rotation by setting the speed to 100. As you can see, the actor is rotating according to the chosen axis passing through the center location. It does what has been implemented but not what is wanted. In order to have the right rotation, you need to rotate around an axis which is orthogonal to the vector from the actor to the center represented by the red line. The second step is to orthogonalize axis. To do this, create an event orthogonalize axis. Let's call the axis vector u and the vector from the actor to the center v. The cross product is an operator which give a vector orthogonal to the two others. Let's create w equals to u cross product v. W is orthogonal to u and v, but this is not the vector wanted for the rotation. To get the wanted vector, use again the cross product. u0 equals to v cross product w. This U0 is orthogonal to V, which is the vector from the actor to the center and is the vector wanted for the rotation. Be careful to do the cross product in the good way. Now you can update the value of axis, but you need to normalize beforehand. Let's call the event in the tick loop. The second step is done. Let's see the result. As you can see, the blue line stays orthogonal to the red line regardless of the position of the actor and of the center. And if you set the speed to 50, you can see the actor rotating around the center. The third step is to rotate around an actor. At first, create a variable for the actor. Then, the idea is to set the value of center location only if the actor is valid. By doing this, you will be able to rotate around a value or around an actor with the same implementation. Add a sequence node. Get the actor variable. Right-click on it. And use convert to validated get. The value of center location is set to the location of center actor only when the actor is valid. The third step is done. Let's debug the result. Print the length of the vector from the actor to the center. Compile. Place another planet and rename it in Moon. Set the x value of axis to 1. Set the center actor to Earth. Set the speed to 10. And simulate. The red line shows that the value of center location has been updated. But if you set the speed of Earth to 20, one length is changing. If you stop and look at Output Login window, Developer Tools, you see that the length of Earth is constant but not the length of Moon. Indeed, when Earth moves, the value of center location of Moon is updated and then the length is changed for Moon. In order to keep the length constant, you need to move Moon as much as Earth has moved. The fourth step is to move the actor as much as the center has moved. You need a new variable to get the old location of the center. Update its value after the rotation. And to move as much as the center has moved, rotate around the old center location and place back the actor according to the new center location. Another point to not forget is to initialize old center location on begin play. Likewise, set the value of center location only if the actor is valid. Then assign this value to old center location. The fourth step is done. Let's see the result. Simulate. Set the speed of Earth to 50. As you can see, both lengths stay constant and Moon as well rotating. The orbit mechanics is completed. This is the end of the video. In order to complete the solar system tutorial, watch the next video. Thanks for watching. Bye everyone.